Ordovician-Silurian. Occurring approximately 444 million years ago, this was the first of the Big Five extinction events. The primary environmental drivers were a sudden, intense glacial period, followed by a rapid warming phase. As the supercontinent Gondwana drifted over the South Pole, massive ice sheets formed, causing global sea levels to drop and destroying the shallow water operational theaters, where most life, such as trilobites and brachiopods, resided. When the glaciers retreated, sea levels rose rapidly, and many oceans shifted into widespread oxygen-poor conditions, delivering a second extinction pulse. This dual pulse event resulted in the decommissioning of roughly 85% of all marine species. Late Devonian. Between about 372 and 359 million years ago, multiple extinction pulses hit the oceans, including the Kellwasser and Hagenberg events, severely damaging reef ecosystems. Rather than an asteroid impact, the leading explanations focus on Earth system changes like widespread ocean anoxia, climate instability, and nutrient runoff, possibly amplified by the spread of rooted land plants. As plants developed deep root systems, they broke up rocks and released massive amounts of nutrients into the oceans. This caused eutrophication, runaway algal blooms that stripped the water of oxygen, creating vast, dead zones. This protracted crisis unfolded over millions of years. Total loss estimates vary by method, but it caused major biodiversity collapse and reshaped ecosystems heading into the Carboniferous. Permian-Triassic. The Permian-Triassic event, occurring 252 million years ago, was the most catastrophic system failure in Earth's history. It was the most severe known extinction, with estimates commonly around approximately 81% marine species lost, with some studies giving higher ranges, and about 70% of terrestrial vertebrate species. The primary kinetic driver was the Siberian Traps, a massive volcanic province that erupted for 1 million years, releasing staggering amounts of CO2. This drove extreme greenhouse warming and ocean acidification. Temperature increases were likely on the order of approximately 8 to 10 degrees Celsius, or more in some estimates. The atmosphere became toxic, and the oceans became stagnant and anoxic. It was the largest known crisis for insects, and may be the only Big Five event to hit insect diversity that hard. Marine ecosystem recovery is often described as taking roughly 5 to 10 million years, with some aspects taking longer. Triassic-Jurassic. Approximately 201 million years ago, as the supercontinent Pangaea began to break apart, a massive volcanic event known as the Central Atlantic Magmatic Province was initiated. This released huge volumes of greenhouse gases, triggering rapid climate shifts and lethal levels of ocean acidification. This event caused very large losses, often summarized as roughly 3/4 of species, including many large amphibians and several reptile groups, reshaping who dominated on land. This operational vacancy allowed the early dinosaurs to seize control of the terrestrial theater, leading to their 135 million year reign. Cretaceous-Paleogene. Occurring 66 million years ago, this is the most famous high-impact extinction event, marking the end of the non-avian dinosaurs. The primary external threat was a 10-kilometer-wide asteroid that struck the Yucatan Peninsula, creating the Chicxulub crater. The impact triggered tsunamis and widespread fires, and it likely caused an impact winter as dust/soot and aerosols reduced sunlight, effects modeled from years to decades. This led to a total supply chain collapse of photosynthesis-based ecosystems. While 75% of all species were eliminated, the event cleared the operational theater for mammals and birds to diversify and eventually achieve global dominance. Holocene/Anthropocene. Unlike the previous Big Five, which were caused by geological or celestial events, the current extinction crisis is driven by the operational footprint of a single species, Homo sapiens. The primary drivers include habitat destruction, overexploitation of resources, the introduction of invasive species, and human-induced climate change. Many assessments estimate modern extinction rates are far above background, often summarized as approximately 100 to 1,000 times higher, though the exact multiplier depends on what groups you measure and how. This sixth extinction represents a unique challenge, as the driver of the crisis also possesses the cognitive capacity to monitor, analyze, and potentially mitigate the ongoing biological fallout. Thanks for watching. If Earth has already survived 5 mass extinctions, do you think this one will end differently? Let me know what you think in the comments. Also, please remember to like and subscribe if you enjoyed this video.